हेलो फ्रेंड्स, नमस्कार। क्लास 12 चैप्टर 10 वेव ऑप्टिक्स के एक और सेशन में आप सबका स्वागत है। इन द प्रीवियस सेशन स्टूडेंट्स वी हैव डिस्कस्ड द वेव फ्रंट। क्या डिस्कस किया था हमने? वेव फ्रंट। और अभी अभी हमने ये चैप्टर शुरू ही किया है, वेव ऑप्टिक्स, जिसमें हम लाइट को वेव मानेंगे। और जैसा कि हमने पिछले सेशन में डिस्कस किया था कि हम डिस्कस करेंगे क्या कि रिफ्लेक्शन, रिफ्रैक्शन, वो सब हम डिस्कस करेंगे। ठीक है, तो आइए उसका डिस्कशन शुरू करते हैं। तो आज हम डिस्कस करेंगे मेनली वो है रिफ्लेक्शन एंड रिफ्रैक्शन। रिफ्लेक्शन एंड रिफ्रैक्शन ऑफ वेव फ्रंट। रिफ्लेक्शन एंड रिफ्रैक्शन ऑफ वेव फ्रंट। ठीक है, ओके। पहले देखिए, अगर हम लाइट को रे मानते हैं, क्या मानते हैं? रे। तो क्या होता है? ऐसा, दिस इज द इंसिडेंट रे, दिस इज द रिफ्लेक्टेड रे। व्हाट इज दिस? इंसिडेंट रे। व्हाट इज दिस? रिफ्लेक्टेड रे। एंड what is this? This is smooth surface. Smooth surface. Okay. What is this? Angle of incidence. What is this? Angle of reflection. Two laws were there. In the first law, angle of incidence equal to angle of reflection, and second, this incident ray, reflected ray, and normal, okay, all lies in the same plane. ऐसा हमने रे ऑप्टिक्स में स्टडी किया था। ठीक है, आज हम स्टडी करेंगे ऐसा ही, लेकिन वेव ऑप्टिक्स में। इसमें वेव ऑप्टिक्स में बच्चों, वेव ऑप्टिक्स में वेव फ्रंट ट्रैवल करते हैं। किस तरह ट्रैवल करते हैं देखिए। पहले तो सिर्फ देखिए बच्चों, ठीक है। चलो मैं थोड़ा सा आपको 3D का इमेजिनेशन देता हूँ। ये जो स्मूथ सरफेस है ना, ये वही स्मूथ सरफेस है, स्मूथ सरफेस। ओके, और पहले ड्रॉ करने के लिए चलो मैं थोड़ा सा प्रैक्टिस कर लूँ। ये वेव ऐसे आएगी और ऐसे जाएगी। ठीक है, ये तो रे ड्रॉ करना बहुत इजी है बच्चों, इसीलिए तो पहले आपको रे सिखाया जाता है। अपने 10th में भी आपने रे सीखा होगा। ठीक है, क्यों? बिकॉज इट इज वेरी इजी टू अंडरस्टैंड। ओके, और अभी वेव फ्रंट में अगर ड्रॉ करूंगा तो वेव फ्रंट कुछ इस तरह दिखेंगे। अच्छा, ये पहला वेव फ्रंट है जो आगे आया। ठीक है, फिर ये उसने दूसरा वेव फ्रंट जनरेट किया। अच्छा देखो, ये ड्रॉ करना बहुत मुश्किल है, मतलब कि ऐसा मुझे लग रहा है। आपको अगर लगता है तो भी बहुत अच्छी बात है। ओके, ये नीचे आया, देखिए ये आ गया 5 में। ठीक है, और उसके बाद ये वेव फ्रंट आया। वेव फ्रंट आने के बाद वो हो गए रिफ्लेक्ट। क्या हो गए बच्चों? रिफ्लेक्ट। तो कहने का मतलब क्या है? वो ऐसे हो गए, अब वो ऐसे जाएंगे। ठीक है, मतलब पहले देखिए वो कैसे आ रहे थे, अब वो कैसे जा रहे हैं। ओके, एंगल कितना होगा इन दोनों के बीच में? ऑलवेज 90 डिग्री। यहाँ पर भी कितना एंगल होगा? ऑलवेज 90 डिग्री। ओके, हम इसको क्या बोल सकते हैं? इंसिडेंट वेव फ्रंट। ठीक है, ये, और ये क्या है? रिफ्लेक्टेड वेव फ्रंट। वेव फ्रंट। ठीक है, देखो ये इंसिडेंट और रिफ्लेक्टेड वेव फ्रंट अभी जो हमने ड्रॉ किया है, ठीक है, वो एग्जैक्टली कैसा बिहेवियर करेंगे जैसा रे बिहेव करती थी। मतलब कि ये दोनों लॉ ये फॉलो करेंगे। ठीक है, अच्छी तरीके से याद रखना बच्चों। ये स्मूथ सरफेस है। अब देखो, ये अगर ऐसा ड्रॉ किया है तो आपको बहुत भद्दा लग रहा होगा, मतलब कि कुछ समझ में नहीं आ रहा होगा इतना ज्यादा। लेकिन अगर मैं इसको 2D में ड्रॉ करूं, पहले तो आपको समझ लेना चाहिए कि मैं 3D में ड्रॉ किया था। अब हम साइड से देखें तो कैसा लगेगा। सी हियर, हाँ, ऐसा। What is this? This is smooth surface. Smooth surface. Smooth and the reflecting surface. और एक वेव फ्रंट आया, पहले यहाँ ड्रॉ कर देता हूँ. ये पहले किधर था? इधर. पहले उससे भी पहले किधर था? इधर. ठीक है. कैसे ट्रैवल कर रहा था? ऐसे एग्जैक्टली परपेंडिकुलर ऐसे ट्रैवल कर रहा था. ठीक है. ट्रैवल किया. ओके, कोई बात नहीं. अभी ये जो है क्या होगा देखना बच्चों. ये पॉइंट सोचो कि हम ए ले रहे हैं और इस पॉइंट को सोचो कि हम बी ले रहे हैं. ठीक है. ये इंसिडेंट होगा. बाद में रिफ्लेक्शन किस तरह होगा? तो रिफ्लेक्शन पहले मैं आपको डायग्राम ड्रॉ करके समझा दूं कि ये देखिए ए जो है ए तो आ गया सरफेस पे, लेकिन बी को भी आना है. तो बी आने के लिए कितना टाइम ट्रैवल करेगा, कितना डिस्टेंस ट्रैवल करेगा? इतना. ठीक है. सोचो कि उसकी स्पीड v है और आने के लिए टाइम लगा t. तो vt जितना ट्रैवल किया, जब तक उसने ट्रैवल कर लिया बी ने स्मूथ सरफेस तक आते आते, तब तक ये उठ गया इतना. सही ड्रॉ नहीं कर रहा हूँ बच्चों में. ओके, सही मतलब कि अच्छा ड्रॉ नहीं कर रहा हूँ. पहले तो आपको समझ में आ गया ना, ये आर है. तो आर है मतलब कि इसको अभी मैं इरेज कर देता हूँ ताकि मैं अच्छा सा ड्रॉ कर पाऊँ. ओके. अभी ये ओके, देखना बच्चों ये आया. पहला जो है ग्रीन वाला जो है ना वो आया. आया मतलब बच्चों की देखभाल करती है वो आया नहीं. वो वेव फ्रंट आया मतलब कि आ रहा है ऐसे, उसकी डायरेक्शन ऐसे. ठीक है. एंड दिस ए बी. ओके, लेट्स से this is a C and this is a D. I will say here, what is AB? AB is the incident wave front. AB is the incident wave front. ठीक है. Okay, then after CD, CD is reflected wave front. ठीक है बच्चों. रे ऑप्टिक्स में हमने क्या पढ़ा था? व्हाट इज एंगल ऑफ इंसिडेंस? एंगल बिटवीन नॉर्मल एंड इंसिडेंट रे. ओके, पर यहाँ पर एंगल ऑफ इंसिडेंस ये होगा एंगल बिटवीन इंसिडेंट वेव फ्रंट एंड सरफेस. इंसिडेंट वेव फ्रंट एंड सरफेस. और ये होगा एंगल ऑफ रिफ्लेक्शन आर. एंगल बिटवीन रिफ्लेक्टेड वेव फ्रंट एंड सरफेस. बच्चों जब बी से सी आने के लिए इतने डिस्टेंस ट्रैवल किया वीटी, और मीडियम तो सेम ही है, इसी मीडियम में ट्रैवल कर रहा है. सो व्हाट यू कैन से दैट this wavefront means what? This CD wavefront may also have traveled the same distance. How much it is? Vt. Okay, and this is a wavefront. AB is a wavefront, and you can say it shows the direction. Okay, here also it shows what it shows: direction of propagation. So you can say that here you will find which type of angle? 90-degree, right angle. Okay, because wavefront and direction of propagation are perpendicular to each other. देखो बच्चों इस तरह ही ड्रॉ करना एग्जाम में आए तो एग्जाम में कई बार बच्चे क्या करते हैं, ऐसा पूछा है तो ऐसा इसके टाइप जैसा ऐसा दिखना चाहिए. तो वेव आई और ये एंगल 90 जैसा दिखता भी नहीं. ठीक है ना, समझ में आएगा नहीं. ट्राई करना कि ये एंगल कैसा दिखे, 90 एंगल बी एंड एंगल डी. ठीक है, समझ में आया? ओके, कोई बात नहीं. चलिए अब क्या करते हैं. इन ट्राइंगल मतलब कि राइट एंगल ट्राइंगल ए बी सी. क्या आपको राइट एंगल ट्राइंगल ए बी सी दिख रहा है? ए बी सी. ठीक है. हम क्या ले सकते हैं? साइन आई इज इक्वल्स टू क्या बोल सकते हैं? साइन आई. देखो ये ऐसी हाइपोटेनियस हो गया. साइन आई इज इक्वल्स टू हम बोल सकते हैं अपोजिट अपॉन हाइपोटेनियस, मीन्स बी सी अपॉन ए सी. बी सी इज हाउ मच? वी टी. Okay, and AC is a AC, no problem about that. Okay, now in triangle ADC, which triangle? ADC, sine R. Can you see the triangle ADC? Huh? Yes, you can see the triangle. Sine R is equals to what? You can say it is AD upon AC. Now what is AD? VT upon AC. See, this is equation number 1 and this is equation number 2. Therefore, from 1 and 2, from 1 and 2, we can say that, we can say that, see, the right hand side is the same. So what you can say, left hand side will also be same. What we can say, sine I equal to sine R. Okay, or I equals to R. You can say pi plus R also, but we will take the physical scenario. That's why I equal to R. This is the first law of reflection that we have proved. First law of reflection. See, one confusion I think that can be in your mind, that sir, you have taken I and R with respect to surface. How we can believe that? Okay, so let me prove that first of all. See, this is a smooth surface. Okay, this is, what is this? Incident wavefront. Okay, now what is the direction of the incident wavefront? This is the direction. Can I say like this? This is the direction. Yes, or you can say in this direction. Okay. Whatever the direction you draw, means in this direction. Okay. Now suppose I draw normal here. What am I drawing? Normal. So if I draw normal, this is a normal. Okay. Then angle between normal and this is a I. Am I right? Okay. But this direction and the wavefront, they are perpendicular to each other. So what this angle will be? This angle will be 90 minus I. Okay, but see, the normal and the surface again perpendicular to each other, these. So this total angle should be 90. So this is 90 minus I. So this will be I. Okay, so might you get somewhat relief that yes, whatever we have studied in the ray optics, same we are doing here. We are not doing anything against the law. Okay, means I equals to R. See here, this incident ray. Okay, how incident wavefront, how it looks? It is coming outside, not coming outside, but actually it is in Z direction. Z direction means what? See, I am drawing here. Means it is like this. Okay, what I have drawn in initially, like this. Okay, a wavefront, reflected wavefront is also there, and normal is also like this. Okay, so what you can say here, normal, incident wavefront, incident wavefront, and reflected wavefront, reflected wavefront, all lie in same plane, all lie in same plane. Okay, so here it is the law of a reflection. One thing, yes, I want to say that here VT and here also VT. Why? Because it is in the same medium. That's why whatever the speed of light, incident light, that will be the same speed of the reflected light, because medium is the same. That's why. Got it? Okay, fine. Now let us discuss what? Let us discuss. Let us discuss refraction of light. Okay, so give heading, refraction of wavefront, refraction of wavefront. Okay, let wavefront is moving from rarer to denser medium. Let's think like that. Okay, moving from rarer to denser medium. Okay, see carefully. What is this? This is interface. Interface means here you can say this is medium 1 having refractive index n1, and this is medium 2 having refractive index n2. Okay, fine. Now here ray means, sorry, not ray, incident wavefront. I will draw incident wavefront with a red color. Let's draw with the red color. This is the incident wavefront. Okay, incident wavefront AB. Okay, AB. What is AB? AB is incident wavefront. Okay. Now here A reached at the interface and it will going to progress in the medium 2. But B is a still in the first medium. See, initially suppose they are here or somewhere here. Okay, they are coming. At that time, speed of A and speed of B both are same. Speed of A and speed of B both are same. So it does not get tilted. It does not get tilted. No problem. No, no, no. Now what happens? See. Here medium get changes, and we know that it is going from rarer to denser. Means you can say here n1 is less than n2. Means here this medium is a rarer medium and this medium is a denser medium. So as light enters in this medium, as wavefront enters in this medium, its speed got decreases. बच्चों यहाँ पर डेंसिटी थोड़ी कम है मीडियम की, पहले मीडियम की, इसलिए वहां पर फास्ट चलेंगे, लेकिन जैसे ही दूसरे मीडियम में एंटर हो गए तो उसकी स्पीड थोड़ी कम हो जाएगी. नाउ व्हाट सी the scenario is that when ray just change the medium, at that time what happens? B, suppose okay, let me use first of all red ink. Let B has traveled this much distance. Okay, and that is how much? V1t. Okay, and in the same time, A will also travel the distance. A will also travel the distance. Okay, see, A is also traveling the distance. But how much? V2t. Okay, time taken is the same. But why A has traveled very less distance as compared to B? B is also traveling in this direction. A is also traveling in this direction. Okay, why? Tell me. Because here medium is somewhat denser. That's why. So now A came here and here is the B. Let's join them. Okay. Now what? Now both will travel with the same velocity. Means what? Now light will travel in this direction. Okay. Initially it is traveling in this direction. Okay. Means what? It gets bended somewhat. See, it gets bended. This is, you can say, as a angle of incidence. Let me first of all give the name A, B, C, D. Okay. AB is the incident wavefront. I will write with the help of red ink only. AB is the incident wavefront, and CD is refracted wavefront. Okay. V1. What is V1? speed of light in medium 1. And what is V2? Speed of light in medium 2. Okay. I. What is I? I is angle of incidence. And R. What is R? R, first of all, let me draw R. This is the R. Angle of refraction. Angle of refraction. How much this angle is the 90? How much this angle is the 90? No problem. And don't forget, this wavefront is the outside. Actually, outside means what? Like this. Actually, it is like this. Okay, but we are seeing from here. That's why we able to see this much only. Okay, like that. Okay. So, what I want to say here is that I in triangle ABC. Now let's start the derivation without wasting the time. In right angle triangle ABC. Can you see that triangle? Yes. Sin I is equals to what? Sin I is equals to opposite means BC upon AC. Right. And what is BC? V1T upon AC. Okay. Now in triangle right angle triangle ADC sin R is equals to opposite upon hypotenuse. So what is opposite? AD upon hypotenuse AC. Now what is AD? V2T. Okay, upon AC. This is equation number 1 and this is equation number 2. Okay, 1 upon 2. I am dividing them. Sin I upon sin R. Just dividing them. Okay, so sin I upon sin R on the left hand side. So in the right hand side, what you will say? V1T upon AC into AC upon V2T. So AC got cancelled out. TT also get cancelled out. And what you will got is the V1 upon V2. Okay. See, we know that N equal to C upon V. N means what? Refractive index of medium. C, speed of light in vacuum. V, speed of light in any medium. Okay. Therefore, N is inversely proportional to V. Therefore, what we can say? N1 upon N2 is equals to V2 upon V1 or N2 upon N1 is equals to V1 upon V2. So what is here? Here is the V1 upon V2. Yes. So what you can say? Therefore, sin I upon sin R is equals to N2 upon N1. Clear? It is nothing but Snell's law. So here we have proved what we have proved? Snell's law. Okay. And one thing, all they are here incident wavefront, incident wavefront, then after refracted wavefront, and normal all lies in same plane. Okay, clear? You can write in this way also. N1 sin I is equals to N2 sin R. Okay, at the time of ray optics we have used this relation much. See, I want to say that if light goes from denser to rarer, then what happens? in fast I will say this is the wavefront, incident wavefront AB. Okay, and light travels this much distance, how much, v1t, in a medium number 1. Okay, but at that time A has traveled this much distance, v2t. Why? Because here this medium is a rare, that's why. Just join them. So here light is traveling like this, but here light is traveling like this, away from the normal. Okay, and rest thing are same. Here n1, here n2. What is only difference is that n1, sorry, not less than n2, but n1 greater than n2. n1 is a greater than n2. Clear to you? Okay, so here we have discussed the reflection and refraction. Okay, one thing I want to discuss, one only small thing. Suppose this is an incident wavefront. Okay, what happens actually? Let's see. This is the A, this is the B. Suppose it gets divided into some parts. That name of this point is a A1, this point is a A2, and this point is a A3, and this is a B. Actually, there are infinite points, but I am taking this much point. Okay. So as the A touch the surface, according to Huygens theorem, what happens that it will develop a secondary wavefront. It will develop a secondary wavefront in which direction? In this direction, opposite. Okay. Why? Because it is not able to travel this opaque surface. That's why. Now, when A1 touches, it develops the wavefront, but at that time A has developed somewhat more wavefront, larger. When A2 touches, it will develop the wavefront, but at that time A1 has developed more and A has developed even more. When A3 touches, at that time A2 more, A1 more, and A much larger. And when B touches, students, at that time A3, this is A2, this is A1, and this is of A. Okay, just combine them. See, I am combining them. Okay, tangentially. Okay, because of some drawing problem, not able to draw exact, but this will be the reflected wavefront. This will be the reflected wavefront. Clear? Okay, and they will grow continuously. So this reflected wavefront will continuously will travel in this direction. In case of refraction, what happens? When it incident here, this is a, okay, this is a B, here A1, A2, that you can say. So as A, like this, A1 this much, and then after, so as the incident they will develop. Okay, and in this way they are developing more, and you will get like this. Okay, here light is going from rarer to, sorry, denser to rarer. Why? Because this wavefront develop more. Why? Because its speed is more, because the medium is a rarer. But if medium is a denser, then this will be short, and you have seen that how it look like. Okay, so basically this happens, but it is not necessary to understand this. Okay, if you understand basic laws and how wavefront behave, then that only enough for you. Okay, clear to you? Okay, so this is for today, that here we have discussed reflection and refraction of the wavefront. Okay, in the next we are going to discuss very important phenomena, that is known as the interference of the light. Okay, thank you and namaskar.